Hello students, as we have learnt about the general properties of equilibrium, that is, the equilibrium constant is independent of the initial concentrations. But if a system at a equilibrium is subjected to a change in the concentration of one or more reacting substances, or the change in the temperature or pressure, then the system is no longer at equilibrium. That means the equilibrium get shifted to a particular direction, either in the forward direction or in the backward direction. So in order to predict the direction of the reaction by making a change in the equilibrium, by shifting the equilibrium, by making the change in the one of the factor which affecting the equilibria. So in order to predict such changes, a principle is used, that is Chatelier principle. So let us discuss what is this Chatelier principle. It states that the change in any of the factors that determine the equilibrium condition of a system will shift the equilibrium in such a manner to reduce the effect of the change. That means the factors which is affecting the equilibrium condition, like the concentration, temperature, pressure. So if any such changes is affecting the equilibrium, that is the equilibrium state, then the equilibrium gets shifted, and in such case it no longer will be in the state of equilibrium. So it either shifted in the forward direction or in the backward direction. So it shifts the equilibrium in such a way that to reduce the effect of the change. So whatever the change is done, either the change in the concentration or in the temperature or in the pressure, so the equilibrium gets shifted in such a manner to reduce that effect of that change. So that will be going to discuss here in this video. So we will be discussing the factors affecting equilibrium. So the important factors which we need to discuss, that is the effect of concentration changes, effect of pressure change, effect of temperature change, effect of inert gas addition, and the effect of catalyst. So these factors which we have to discuss, these are the factors which is affecting the equilibrium. So we'll be discussing these one by one. First, let us discuss effect of concentration change. The concentration changes can affect the equilibrium. That means in general, when the equilibrium is disturbed by the addition or removal of any of the reactant and product. So in order to discuss the effect of concentration, let us consider an equation, that is H2 plus I2 give rise to twice HI. Here we will be discussing this effect of the changes on the concentration of this reaction. We can explain with the help of a graph. Now here the graph is the plot, that is between the concentration and the equilibrium stages, which is shown here with time. That is the concentration versus time plot is shown for this equation. Now look at here. In this equation, on the reactant side we have H2 and I2, and on the product side we have twice HI. So we know that at the equilibrium stage, the concentration of reactant and product does not changes. So that means when we make a plot between the concentration and the time, we can see that the plot is straight line, that is parallel to the x-axis, that is concentration of HI, that is parallel, concentration of I2 is parallel to the x-axis, and the concentration of H2 is parallel. So that means this stage is, this stage is showing the equilibrium stage, where the concentration of H2, I2 and twice HI is not changing. That's why it's plot, when we look at here, it is parallel to the x-axis. But if hydrogen, that is one of the reactant, is added to the reaction mixture at equilibrium, then the equilibrium of the reaction is disturbed. That is very clear from this. You can see now the plot is no longer straight line. You can see now here it is not parallel. That is the plot for HI, H2 and I2 is no longer parallel. That means the equilibrium get disturbed. Now in order to restore it or to reduce the effect of this change, the reaction proceed in a direction. That is in the direction in order to consume the hydrogen which is added. That is, you can see in the forward direction. Now the reaction get moved in the forward direction in order to reduce the hydrogen which is added. So that is, when it moves in the forward direction, this hydrogen get consumed and it get converted into HI. So that is what it says that when one of the factor which is affecting the concentration, that is affecting the equilibrium, is added or removed, then the equilibrium get disturbed and it get disturbed and it shift in a particular direction in order to reduce the effect of that change. So now you can see here, as the concentration of H2 is get raised here because hydrogen is added. Now since in order to reduce this one, the concentration of hydrogen, in order to reduce it, it moves in the forward direction. Now look at here in the plot, you can see now the plot for hydrogen is little bit down. It shows that because now the equilibrium is no longer remains, it get shifted in a forward direction. So the concentration of H2 now it get decreased, and when the concentration of H2 is decreasing, I2 will also decreases because H2 and I2 only makes HI. So you can see the plot for hydrogen and iodine both is moving down, but the concentration of HI is raised up because as the reaction now it is moving in the forward direction, that is a formation of product is taking place. Therefore we can say that here the plot is for HI is slightly raised up. But after some time it is seen that now again the plot for HI, I2 and for H2, now again it become parallel to the x-axis. Now that means we can say at this stage we can say that equilibrium is re-established. So look at very carefully this plot. This area shows that the equation, that is the reaction, is at the equilibrium, but with the addition of hydrogen for some time, that is the time between the T2 and T1, here we can say that equilibrium get disturbed. So for a short time we can say that the reaction will not longer be in the equilibrium stage. It gets shifted in the particular direction to reduce the effect of the change, and finally that equilibrium is re-established. So this is what actually the Chatelier principle says, that when the concentration of any of the reactant or product in a reaction at equilibrium is changed, then the composition of the equilibrium mixture changes so as to minimize the effect. So that is what it is described in the plot, is given in the explanation through Chatelier principle. So we can say that if the reactant is added, then the equilibrium shift to forward direction. And if the product is added, then the equilibrium is shifted to the backward direction. That is important here. When the reactant is added, so when the reactant is added, so where the equilibrium shift, that is in the forward direction, because to reduce the concentration of reactant, it moves in the forward direction, and but when the product is added here, so the reaction moves in the backward direction in order to reduce the concentration of product. So that is what the Le-Chatelier principle says. So here it is important for the reactant and the product. We can say that if the reactants is added to the equilibrium, then the equilibrium shift towards forward direction, and for product it is in the backward direction. Next term, we'll be discussing about the effect of pressure changes. In order to discuss the effect of pressure at the equilibrium stage, let us consider an equation, that is CO plus thrice H2 give rise to CH4 plus H2O, where the reactants like CO and H2 are in the gaseous state, and the product like methane and H2O are in the gaseous state. So according to the Le-Chatelier principle, that is, if the pressure is increased, then the equilibrium shift towards the lesser number of gaseous moles, and if the pressure is decreased, then the equilibrium shift towards large number of moles of gases. That means when you look at this equation, for this equation, this is the reaction that is in the forward direction. Now here when you look at here, the number of moles of gaseous products are 2, because 1 mole of methane and 1 mole of hydrogen according to the balanced equation. So the number of moles of gases is 2 here on the product side, but on the reactant side here 1 mole of carbon monoxide and 3 mole of hydrogen gas are there. That means total 4 mole of gases are there on this reactant side. So according to the Le-Chatelier principle, when the pressure is increased at the equilibrium stage, then the equilibrium get disturbed and the reaction moves in a particular direction. Now if the pressure is increased, then the equilibrium shift towards a lesser number of gaseous moles. Lesser number of gaseous moles mean, where is the less number of gases in this equation? That is on the product side. So we can say that the equilibrium gets shifted on which direction? That it is on the forward direction. But when the pressure is decreased, then the equilibrium shift towards larger number of gases mole. That means the equilibrium shift towards the backward direction. So depending upon the number of gases moles on the reactant side and product side, the pressure, if it is increased, then the equilibrium shift towards where there is a lesser number of gases moles. But when the pressure is decreased, then it is shifted toward the larger number of gases moles, because the pressure is due to the gaseous molecule. So if the pressure is increased, so according to the Le-Chatelier principle, that the equilibrium shift in that direction where to reduce that effect. So the pressure can be reduced by reducing the number of gases mole. That is, here we can write, that is in the direction where there is less number of gases moles. So that is the effect of pressure change. Next is the effect of temperature. For this, let us consider an equation, that is N2 plus H2 give rise to NH3, that is a formation of ammonia. This equation is called as Haber process. Now according to this here, the reaction that is in the forward and backward direction, the reaction is for this, that is forward direction is exothermic, but the backward direction is endothermic. That means formation of ammonia is exothermic, but is the decomposition of ammonia is endothermic. So exothermic, the process in which the energy is released, and the endothermic when the energy is absorbed. So here forward direction the reaction is exothermic, but in the backward direction it is endothermic. So according to the Le-Chatelier principle, if the temperature is increased, then the equilibrium shift towards the direction of endothermic reaction. That means if the temperature is increased, now the system is having the greater temperature, so definitely that temperature has to be reduced according to the Chatelier principle. So that because of this, the equilibrium gets shifted towards the endothermic reaction. That means if the temperature is increased of the system which is in the equilibrium, then automatically the reaction will move in a direction of endothermic reaction, where that increased energy is get absorbed. That reaction is endothermic. But if the temperature is decreased, then equilibrium shift towards the direction of exothermic reaction. That means when the temperature of the system, if it is decreased, so in order to make the changes in that effect, that is to reduce that effect, the reaction moves in a exothermic reaction direction. That means here in this equation, the reaction moves in the forward direction, because in the forward direction there is an exothermic reaction. So according to the Chatelier principle, if the temperature is increased, then the equilibrium shift towards the direction of endothermic reaction. But if the temperature is decreased, then the equilibrium shift towards the direction of exothermic reaction. That means in this equation, if the temperature is decreased, then the reaction takes place towards the forward direction, because the forward direction is exothermic. And if the temperature is increased, then the reaction should move in the backward direction, that is endothermic reaction. Next, that is the effect of catalyst. Catalysts are the chemical substances which increased, or we can say which accelerate the rate of reaction. Let us consider one equation, that is twice SO2 plus O2 give rise to twice SO3. That means the oxidation of sulfur dioxide gave rise to sulfur trioxide. In this reaction, V2O5 act as a catalyst. So, what is the effect of catalyst? Because catalysts are the chemical substance which accelerate the rate of reaction. So, as here, the catalyst does not shift the equilibrium in any of the direction, because it is equally affect the rate of forward and backward reaction. That means if it accelerate the rate of reaction in the forward direction, in the same rate it accelerate the rate of backward direction. That means again the rate of forward and backward reaction gets same. So therefore we can say that the catalyst does not shift the equilibrium in any of the direction. Next, the effect of inert gas addition. If the volume is kept constant and an inert gas such as argon is added which does not take part in the reaction, then the equilibrium does not get disturbed. That means it remains undisturbed. This is because the addition of inert gas at a constant volume does not change the partial pressure or the molar concentration of the substance involved in the reaction. So as when we add the inert gases, it does not causes any changes in the partial pressure or the molar concentration of substances. So because of this reason, we can say that the equilibrium remains undisturbed. So this is about the effect of inert gas addition. So what is important point here? That is the equilibrium remains undisturbed. So in this video, we discussed about the factors affecting the equilibrium. That is, we have discussed about the factor, that is concentration, second temperature, pressure, and the effect of a catalyst and the effect of inert gas. So this is all about this video. Have a nice day.